Workloads rely on much more than the model itself. Storage, compute, identities, networks, containers, and managed services all shape the security picture. In this section, we'll use CSPM to connect those pieces, expose risky misconfigurations, and identify attack paths before attackers can use them. So far, we've built the security foundation: architecture, identity, access, application controls, guardrails, and RAG protection. Now we move into the cloud layer where AI apps, pipelines, vector stores, notebooks, containers, APIs, and managed services actually run. The goal is to catch posture risks early, before they become AI incidents. AI environments rarely live inside one tidy service. They pull from storage, notebooks, pipelines, GPUs, APIs, and managed AI platforms. That creates many places where a simple misconfiguration can become serious. Exposed training data, leaked prompt logs, stolen model artifacts, or an open inference endpoint. Strong posture means assessing identity, network, data, workload, and runtime together, then using CSPM to prioritize the fixes that reduce real AI risk fastest. Think of the AI cloud attack surface as every place where data, models, and compute become reachable. Some risks are familiar cloud issues: public buckets, open APIs, broad admin roles, and flat networks. Others come from AI workflows, notebooks, vector stores, model artifacts, and experimental containers that move faster than security review. The key idea is simple: every shortcut that helps teams build faster can also become an attacker's path into sensitive AI systems. Storage is a high-value target because it holds the raw material and outputs of the system: training sets, embeddings, prompt logs, model weights, customer data, and intellectual property. Start with exposure. No public buckets, shares, snapshots, or data lakes. Then validate classification, encryption, key ownership, and access logging. Finally, monitor behavior. Bulk downloads, unexpected replication, or unusual service principals can signal data theft in progress. Treat every AI-facing endpoint as a controlled entry point, not an open door. APIs, dashboards, notebooks, vector stores, and model runtimes should not be directly reachable from the internet. Route traffic through an API gateway or WAF, then enforce authentication, authorization, rate limits, and restricted ingress. Keep sensitive services on private endpoints inside segmented networks, so one exposed component cannot easily become reconnaissance, endpoint abuse, or lateral movement into training and data systems. In cloud AI environments, identity is often the shortest path from a small mistake to a breach. A notebook user, pipeline role, service account, or CI/CD deployer may look harmless on its own. The risk appears when permissions combine: reading sensitive data, managing keys, and deploying code. That creates a toxic path to compromise. Reduce the blast radius with least privilege, just-in-time elevation, and continuous monitoring for unusual privilege use, cross-account activity, and unfamiliar locations. Notebooks are excellent for fast AI experimentation, but unmanaged notebooks can quietly become a breach path. A data scientist may paste a key, use an overly broad storage role, install an unverified package, and export sensitive data without recognizing the risk. The answer is not to ban notebooks. It is to wrap them with SSO and MFA, scoped identities, secret stores, isolated networking, package controls, and activity monitoring. Containerized AI workloads are only as secure as the path from build to runtime. First, block vulnerable or unsigned images before deployment. Then prevent dangerous execution settings: no root users, no privileged mode, limited capabilities, read-only file systems, and clear resource limits. Kubernetes should enforce these rules through admission control and policy as code. At runtime, monitoring must watch for unusual processes, network calls, file access, or signs of container escape. Prisma Cloud is useful because AI security is not one control. It is a lifecycle. Begin with cloud posture checks for exposed storage, weak encryption, and compliance drift. Then protect the workloads: containers, hosts, images, and runtime processes. Add identity risk analysis to find excessive permissions and indirect access paths. Finally, enforce policy as code, so issues are caught in templates, pipelines, and deployed resources. The goal is continuous assurance from build to runtime. In practice, Prisma Cloud helps turn AI governance into an operating model. It maps AI infrastructure to standards like NIST, CIS, ISO, and SOC2, then checks controls such as encryption, exposure, logging, regions, tags, and identity permissions. When runtime behavior looks risky, findings can flow into tickets, SIEM, or SOAR, so teams can remediate and verify closure. Wiz is useful because cloud risk is rarely a single finding. An exposed workload may not be critical by itself, and an over-permissioned role may look routine. But when exposure, a vulnerability, identity access, and sensitive AI data connect, they form an attack path. Wiz builds that graph across resources, permissions, reachability, and data context, helping teams prioritize the combinations most likely to lead to training data, model artifacts, or vector databases. With Wiz, prioritization means combining signals instead of reacting to every alert equally. A public resource is concerning. A public resource with a critical vulnerability, privileged identity access, and sensitive AI data becomes urgent. The graph connects those factors, including model access and data sensitivity, so teams can separate low-impact misconfigurations from exploitable business risk. The result should be clear ownership. Platform, cloud, security, or AI teams receive the remediation work that matches the risk. CSPM findings matter when they translate into a hardened target state. For AI workloads, that means separating experimentation, training, evaluation, and production paths, then protecting each one with private access, encryption, and secure storage. Containers and compute should use approved images, vulnerability scanning, non-root execution, and runtime monitoring. Workload identity should replace long-lived secrets. Centralized logs, audit trails, and alerts provide visibility across model, data, and infrastructure flows. Together, these controls become the operating baseline for secure AI delivery. Cloud posture is the foundation for secure enterprise AI. The biggest risks come from connected weaknesses, exposed data, risky identities, vulnerable workloads, and weak boundaries. Use CSPM to prioritize what matters, then harden with private networking, least privilege, secure storage, hardened containers, workload identity, and monitoring. Next, we'll move into supply chain and model risk.